Hi, so this video is meant to be a project reproducibility and use case of my real-time emotion detector. First of all, to reproduce this project, please make sure you have all the prerequisites. So install like a source CLI, Terraform, and Docker, and install all the required package in here. I already have all the list in here. So in order to do this, please navigate to the reproduce page. In here, I already described all the steps necessary to reproduce the project. First of all, please open the directory that you would like to reproduce the project in and clone the project. I create the code with a window operator in mind, so not all this may have work in Linux. I apologize for that, but I'm not really sure if there are any other issue that could cause from being Linux operator. So anyway, after you are able to run after you clone the project and install all the prerequisites, please make sure that you have the model. So there's two ways to do this. I have already trained the model. The model is in here. I have uploaded to Google Drive. So you can download the model right here. If you would like to train it yourself, please download the data from Kaggle for 2015, and you can use the code in here as an experiment that I experiment the actual model project itself. It's not the full code. I unable to save all the resolve my training, but yeah, anyway, you can try that. But to reduce the time of reproducing a bit, the code in here should be the model should be downloaded in here. Once you download the model, please put the model in this specific folder in the cloud model test right here. There's a lot of paths that rely on it being here, so please make sure it's right there. The next thing we're gonna do is, if you're on Windows, please make sure you open Docker Desktop. This I'm not very sure for Linux. I believe you have to install Docker and it will operate in the background, so you may not need to open this. But after you open, please run make Docker build. This will build the image for the model and everything. Since I already created the image, it's already cached, so it's pretty fast. Next thing we're gonna do is we're gonna run easy login. This will pop up a window for you to log in. After you're done, you'll see this message, and yeah, this step is required for any further Terraform create and further later down the line. After the login, please run make infra setup. This will initiate the Terraform project for any necessary module that you need to download or any requirement on the file that you need to if you need to create it. For this, you can change the file requirement right here. Please please note that if you change anything here, you may also need to change the data.env file right here in terms of the container name and image name, for example. After this done, it's gonna tell you that it's gonna create 10 resources. So if there's nothing wrong, if you like to check, please do so. Then next thing we're gonna do is create the registry. This is going to be the container registry that we're gonna push our image that we have created before to the cloud. I'm gonna pause the video for now since it's gonna take a couple of minutes to do. Okay, it takes a minute or so to create the resources. Now that the resource is done, you will need to wait a couple of minutes to it to show on here. Sometimes it might not show right away, so please be patient and refresh it. After it's created, the repository is now empty for now. So we're gonna push our image that we have created before up here. You run this command. As before, this is gonna take a while since the image is quite big in size. So I'm gonna pause the video a bit and make sure it's finished after it's done. Okay, now that I have finished, it took like 2 to 3 minutes to do this. After it's finished, you can go into the repository again. You will see that the model is now pushed to the registry container registry repository. It just been pushed recently by 5.2. So the next step after the data has been pushed, we can now create the rest of our resources, which is all the store function, blob storage, the anomaly detector, and intelligent insight or whatever from Azure. But anyway, I will come back again after this is done. Okay, is that finished create all the resources? So now that it created, now that it created all the resources, we can go and check into the Azure again. Now you will see that the Azure function is now created. If you go into the function, you will see one endpoint. It's right here. You go to the deployment center, you will see that this function is now configured to have a webhook URL with our container registry we just created before. So anytime there's a restart on the function, it will repull the image to create the function again, or any like update to the function itself. You can select the log to see if the image is being created at the moment or what it's doing. It takes a while to load, so please be patient with it. Yeah, you can see that it basically created all the data and now it's ready to run. So now that we create the function, the next step is to test out our function. So in here, in order to test a function, you will need to have some example data. In here, I have prepared some example data, basically just an image and a video. So once you have the data, please put it into the input folder right here for the image, and for the video in the video folder. Okay, so next step is we're gonna test on the cloud first. In order to output the cloud endpoint, please run this. It will output the function URL. If it doesn't work for whatever reason, you can also go to the function itself right here, and you can select the get function URL to get the endpoint. It's the exact same thing. So please keep in mind if somehow it doesn't work. Just copy this. Once you get this, copy this and put this into your .env URL file. This will be the URL that we need to make requests to. Now, first thing first, we're gonna try on the image. So right now, as you can see, output image is empty. We're gonna run make pretty in prod. This will send the data to our URL. In the URL endpoint itself, you go into the monitor and log. I'm not really sure if it's gonna show in time or not, but yeah. It will basically connect to the application inside, and you can see real time and what the function is doing. So anyway, I'm gonna run that again. So you can see what happened in the function in here. So the function received the request for each image that we have sent. It receive it and just send it back. You can see. Yeah, you can basically monitor the function from here, the application inside. Please note that if you somehow make adjustment to my file and doesn't have application inside enabled, this function will not work. Anyway, after the image is processed, it will return an output of the image itself with the prediction. You can see, okay, at the moment, what is the probability and the result of the image, not that. Next thing we're gonna try is a video. Please note that the video is gonna take some time to process. So after you make the request, you can check in here that it actually received the request. It will take some time though, so yeah. Yeah, as you can see, it received the request, and it's gonna load the model and making prediction, but yeah, it will take some time. So I'm gonna pause the video and come back when this is finished. Okay, it's finished processing. As you can see from the log, the request come in at 8:56. Yeah, it take like 3 minutes to like process the data, so please keep in mind it could take a while. Anyway, after it's done, you can see the output right here. It's basically the video itself. It will be a bit fast. You can decrease the speed depending on your like player. I didn't really adjust the speed of the video much, so this could be improved in future like update. But anyway, this is the prediction result. It will return the data with the predicted level and the probability at the time. It can work with multiple phases. So yeah, another deployment method model that we have is the local deployment, which is basically what this model intended to be used for. So I delete the output image just now. For local use case, you can run image light. This will basically the exact same thing with the with the cloud one, it will process the data in the image that we have, taking a while. Let's see. Oh, sorry. The additional function of the local deployment is that I will have the property of the at the time. What is the property showing? So I can press Q to process the data in each image if you like to see at the moment, like what is the emotion that it predict. So maybe you can improve the model that way. But yeah, anyway, this is the additional like functionality that we have. And another thing we can do is a video. So we can run predict with lights. This one will be the exact same thing, but in the video version. Here for this, you can see the probability in real time. If you select the image, it will stop the video. So yeah, please keep in mind that. So anyway, it's the exact same thing that is done in the cloud, but for this one, there's a probability that you can see what is it doing at the moment. For multiple phases, also work. For multiple phases, it will always detect whatever the first image is. I don't want to clock the clock the scheme too much, so this is how I implement this. But yeah, it could be moving differently. Another functionality you can have is if you have a webcam, you can run the live data to feed the data into the model itself. So yeah, right here. All right, you can make the real-time prediction and for the like webcam or something like that. It's pretty useful if you maybe have another session with a person and you would like to detect their face in real time or something like that. So this also works. It also works with like multiple faces before. It would focus anyway. So yeah, you can press Q as before to stop the video, and then after you're done, it will output a video right here, the exact same thing. But yeah. Anyway, so after you're finished with the project and reproduce and everything, you can run make infra down P. This will plan all the resource that we have created before for this sorry for basically Terraform to destroy. You can also go into Azure itself and select the resource group, and you can see all the resources that we have created. And after you check that the resource that you have created is the resource that it's going to destroy is the exact same thing that we have created and not like some other resources. You can run infra down dash c to basically commit to the destroying. I'm gonna wait a couple of seconds. It shouldn't take that long. Yeah. So yeah, there's 10 resources to destroy. It's the exact same 10 right here. If that's not an issue, just run this, and it will take some time to destroy all the resources. So I'm gonna stop the video right here. So if you have any question that you'd like to ask about the model or any other issue that you have, you can feel free to talk to me in Slack. But anyway, thank you for watching.